I'm a big fan of how they have it divided into like subcategories, and you can kind of delve for depth in one of those categories, like embedded, for instance, or algorithmic, or you can go for breadth and kind of get this really big cross section. There's a lot of representation of people in different skill sets within C++.
I'm Sherry Sontag, and I am the journalist in Bloomberg Software Shop. Originally, they hired me because they thought I could get people to talk to me. But honestly, I think where I'm most effective is I am obsessive about asking questions.
And I'm CB Bailey, and I work as a software engineer, and I've been at Bloomberg for a little bit over a decade. And for the last 5 years, I work in an infrastructure team, the one responsible for our messaging framework, and in particular, I work on the libraries that support that, and a code generator tool also to support application developers as they use our messaging framework.
So the other day, maybe a couple months ago, we had put out a request for comment. After about 2 years of work, we wanted to float a series of recommendations for changing the way we used our code generator. And one of the first comments was that we had violated something called the principle of least astonishment. And I was trying to figure out what I was going to say to this when all of a sudden the people in Bloomberg started hopping in and saying that they were anything but surprised. And they were talking about how they appreciated what we'd been doing. To be fair, the RFC had a lot in it. Usually you do a request for comment and you're changing one thing. We were changing a whole series of processes, but we had been introducing them one after another. And as we negotiated these with the teams across engineering, people were changing their cookie cutters, they were changing their documentation. Really, the RFC was just to make sure we caught all the rest of the folks that needed to be considered. We did, though, violate the principle of least astonishment, because without planning, we had ended up engineering a really significant initiative that impacted thousands of libraries, ensured the best features were used to tool them, made it easier to continue to modernize our generator, and we did it without risk. And we did it by winning the consensus and participation of hundreds of our colleagues. Our partnership kind of happened. We didn't have a lot in common, or at least not on paper. We were on different teams. We were in different part of the org chart, different continents. And do you remember deciding to work together?
Well, I still haven't.
We weren't assigned this. It wasn't a formal project. In fact, I think so many of the problems we ended up solving were bloat that hadn't yet happened. I'm not even sure that our bosses know how significant it was.
Yeah, I mean, we're both kind of like in infrastructure, but I'm kind of very much on the code front. And I guess some of the frustrations that I've kind of had in my role is discovering by accident teams that are kind of like using our tool, but not in the way they intended and in a suboptimal way. And yeah, our partnership kind of like actually helped get kind of my message across of how we should be using things.
And also, Bloomberg is 40 years old. We have 50,000 libraries. And everybody at this point was looking at our library architecture because things were getting so big that we were worried that our large container executables were going to be too big to build. And you know, there's nothing more Bloomberg than the ability to find a good idea and just run with it. The one thing that is more Bloomberg is the fierce independence of the people we had to deal with. So we were going to get nowhere without their buy-in.
Yeah, so I guess a bit of kind of like history about the way we used to work and the way we're kind of trying to work now would probably be kind of a good thing. So, I mean, Bloomberg's been kind of providing a continuous service since 1980, is it? I mean, yeah. a lot longer than I've been at Bloomberg. And initially, kind of end user requests would typically kind of come into our system, be handled on a single machine in a single executable, and different teams providing different areas of functionality would essentially just provide a library, and the communication between code supplied by different teams is essentially just direct library calls within the same executable. Now, obviously, as we grow and add more and more functionality, this becomes already was pretty unsustainable. So for a long time, Bloomberg was trying to kind of move to more modern architecture, so a classic client-server architecture where to gain answers to a question provided, with functionality provided by another team, you'd send a request off to like a remote service and get a response back.
Like for 20 years, right?
Yeah.
So you take all this functionality out of the executable, but you have to stick something back in a client library to make sure the executable can still communicate with the now moved code. So, and also, but the win is obvious, except for the fact that in order to get more people to do this, CP's team created a code generator. It precedes Google's, it precedes Adobe's, it is Bloomberg's now almost 20-year-old code generator.
Yeah, so it predates me at Bloomberg by a considerable way. So I did a little bit of kind of digging to see, what happened in the beginning. And the principal kind of value that the initial release of our code generator brought was the ability to generate a complete service executable. So essentially, Unix kind of socket listener, TCP/IP, classic standalone executable that could receive connections and send kind of responses back. And the framework that we generated for service owners was schema-driven. So a schema kind of defines the shape of requests and response. We happen to use XML schemas, so XML schema definition language is XSDs. It was probably still is a reasonable choice. It's not the most beautiful thing to hand over, but it certainly fills the purpose. So you'd take a schema where you define your the requests that you want to handle as a service owner and the shape of the responses that you want to send back. You'd give the schema to the code generator, and the code generator would create a complete executable. It would start up, listen on a socket, handle incoming requests, decode them according to from bytes on the network according to your schema, and then invoke a function based on kind of structured C++ types that basically passes you a request and says, hey, return with a response. And that stub function is the only thing that application developers have to write, and they can write that in terms of, they just have to write the business logic. They don't have to worry about any of the network code.
So over 20 years, more and more functionality comes out, more and more client libraries go in. They're kind of bigger than anybody expected them to be. And then something unexpected also happens. The ability to generate these shared value semantic types. We're a financial services company. There's a type for company name. There's a type for president name, first name, last name. There's a type for annual report date. And people start to share these. And then people start to generate these libraries outside of the service network. So suddenly our effort to shrink things is like kind of, 2 steps forward, 1 step back.
Yeah, so I mean, as I mentioned, the principal value of the code generation was generating these service executables, but also in order to kind of complete the story, it would generate the client-side library. So the service is particularly interested in decoding requests and encoding responses. But if you're going to use the service, you're going to make a call to the service, you'll want to encode those requests, send them across the wire, and then decode the response. So that client part of the story, encoding requests and decoding response, can be generated as a library by the code generator. And as it's a schema-driven thing, you can just generate these value semantic types even if they don't form part of a request and response. So yeah, I mean, the generator's kind of like has a lot of uses. But
here's the thing. When you need a service step, when you need the thing that's going to make your service work, and what's it doing like what is it doing on the server side again?
So, I mean, there's a lot of functionality that we kind of put into the services. So, I mean, the core functionality of the network listening, it's got a thread pool, so you can handle multiple requests at once. It provides a logging framework, metrics, so that you can see, almost live graphs of how of your throughput of your service, which requests are taking too long, and things like that.
So we have this great tool, but now we're also making thousands of other libraries that need to be much simpler. And all of these options are all potential gotchas.
Yeah, so when you publish a client library that gets linked into a task that you don't know about, is owned by a team that you don't support, sometimes some of those choices you make are not optimal, and it only becomes apparent when somebody else is kind of linking it. So.
Well, and also, weren't you getting complaints that you're out somehow every generated library was owned by CB, that that your code was too big?
So yeah, I mean, as we mentioned before, we kind of like had a issue with the size of some of our largest tasks, and that actually came to quite a head when we started. Probably about the time we started working. So our team got pinged in particular because the code that we generate was responsible for a large amount of size, of just raw code size. And it's kind of like, well, sure, our team does generate the code, but it's based on, vast schemas that are authored by other teams. So it's kind of like trying not to finger point too badly at each other. It's kind of like, okay, so what can we do? Can we make the generation more efficient so that the classes that we generate less code? Can we encourage other teams to share more types so they're not duplicating stuff? So yeah, that was a kind of collaboration.
And when CB gets her head under the hood, I start making a lot of noise. I start calling developers. And every time I saw somebody's source code, I wanted to know why people had so many different choices for making what seemed like they should be similar libraries. And everybody would be like, yes, I get it, small is better, but we're special. Our use is different. Well, can you explain why? Well, no, we've always said it this way. I know it has to be different. So I started I'm a journalist. I find the expert in the room, right? I mean, if I was writing about the law, I would find the lawyer in the room. It was a lot of fun to cover insider trading that way and get the prosecutors and the defense lawyers in the same day. In this case, I found CB. And I would say, okay, they are having a really hard time explaining why they're special. Can you tell me if they really are? And we just start talking first once a month, then once every other week. I started scheduling things. I'd batch them because I know CB really likes to get an idea of what they're going to be looking at and really think about the code before she's on the spot. And then we just start talking once a week. My team, that was pretty typical. What did you do with your day? Well, I spent the morning with CB. On CB's team.
Yeah, so I have a lot of responsibilities. I'm kind of like, I've got my own code to write. I've got my colleagues' code to review. And so I talk to my my team leader, and sometimes I express things that sound like frustration. So I was saying, yeah, no, I had quite a long conversation with Sherry the other day, and we've got a lot of teams that are doing things that are kind of not great, and that took a while to sort out. And naturally, my team leader's reaction was to go, well, did you need me to kind of like shield you from this so that you can kind of work on what you need to work?
From me.
And what I said is, well, no, actually, the stuff that we're getting to see is actually stuff that we wouldn't otherwise see. And I think it's really valuable that we're able to kind of like feedback, find these teams that are using our code generator in a way that we didn't expect, in a way that we think is suboptimal. And actually, we're getting visibility of issues that we wouldn't otherwise through this conversation and these sorts of conversations.
I have never been so glad to be kept in the dark. She was so kind to me. She didn't let on that any of this had happened until we were writing this talk, because I think I would have wanted to hide under my desk.
You never asked me directly.
Actually, that's true. I did ask you the question when we were getting together. What did they think when I started showing up? London to New York, but still. And but we start working together, and we started listing other teams, and we ended up looking at how libraries would be built, how they could be named, what they can hold, which made some people very unhappy, and what options we wanted to make impossible, at least for client-side libraries, as opposed to services. And we got a boost with CMake.
Yeah, so as a whole, a lot of teams are kind of moving to CMake, and something that was kind of like initially done by the community that my team took over was a CMake wrapper around our code generator. And that's kind of like, that was really important for a lot of the work that we did, because the CMake module that allowed you to call our code generator meant that it was simple to invoke the code generator at build time. Now, before the existence of this module, with one minor exception, sorry, I've never mentioned this before, I've just thought of it on stage for the first time ever. Anyway, now it's too much detail. But mostly, before the CMake module, the general best practice, or the practice at the time, I hate to use the word best, was to run the code generator, check in the results, and run with it. And of course, what that means is if we change the way the code generator works, the benefit of those changes aren't realized unless somebody actually goes and reruns the code generator, which was generally a manual process and therefore generally just didn't happen.
And from my point of view, remember, those of you who have heard me speak before will remember that I have learned C++ from my colleagues as I've needed things. And I now have this really easy way of looking at the source code. There was an XSD, there was a CMake list.txt, basically a list of instructions. And every little detail became just another set of questions. And CB knew exactly where to look under the hood to figure out how to fix it. So one of the things we started with is the idea of codec choice. There are several codecs that were being built for every client library, into every client library. It's one of the things that were making them so big. And I asked CB why we couldn't limit people to one. And one of the things she taught me was if people have clients out there somewhere and you make them simplify the client library, we're going to cause runtime breakage for somebody. And she wanted me to leave existing code alone. So I started looking at new libraries coming into the system and insisting that they build with only access to one codec. In the meantime, the question began to intrigue you.
Yeah, so I guess a little bit of more background around our service framework. So, I get the clicker now, it's very important, and I can't remember which way the buttons are, so I'm going to get it wrong the first time.
We were watching somebody at a talk before, and they had stress balls every time they got something right or wrong. We needed a box of stress balls for every time we get the clicker wrong here.
Yeah.
They didn't have any. Anyway, come on.
So when I mentioned earlier that the service stub that we generate based on your XSD takes bytes from the networks, decodes them into a structure type that is the request, and then sends a response back. We actually, as a framework, support a number of different encodings. So our, I guess, standard one is BER, which I think is part of ASN1 standard. I don't know the details. The great thing is I don't need to know the details because I've got another team that actually implements the codec.
Show them.
I'll get that. I don't want to. Okay.
I just know it's a cool slide.
It is a cool slide, but I don't want everybody staring at my cool slides. So in the client libraries, we also support these codecs. But most people, because the framework supports all of these codecs, on the client side, you only really need access to one codec that's just going to work because they all work just as well as each other. On the service side, it makes sense to support a number of codecs, kind of especially for other languages and frameworks that maybe don't have a BER library, but maybe talking JSON is easier. So on the service side, it makes sense to have all of this support. But on the client side, it's just code that we generate a lot of code that is basically not used and not useful. So a little bit of a story about, or a little bit of a framing about how like a typical application that wants to call a service is structured. So in the box on the top left, stage, what have you. There's a red box, and that is application code. So what the red represents is code that application teams actually write, and it's predominantly in business logic, and you don't have to worry about the details of encoding or the details of the network. And then my team basically provide the client API. We support a number of client APIs, but for the purpose of this talk, we support a client API. And so the client, so the request that the application makes when it wants to call a service is basically send request. And that request will be a template function, and it's templated based on a request type that is specific to a service. So our API is basically a templated API. We then so in the bottom right, there's a codec API, and this is provided by another team. Again, a template library. So provided your request type supports what we call introspection, and sitting in the keynote on Monday, I'm kind of thinking, I wonder if reflection would be a suitable replacement for that. And I think the answer is almost, which is kind of quite interesting. So the codec API basically allows like a structured type that has certain properties to be serialized in one of the different codecs that I mentioned previously. And so our client API does that serialization. It's a template-to-template kind of invocation. And then once we've got the bytes, we call the transport API. The transport API is provided by another team, and they've got all the expertise in networking, so mainly TCP/IP networking, but maybe Unix domain sockets, maybe some other thing that we haven't thought of yet that we're going to use. HTTP2, all of the good stuff that the different transports that we might want to use. And then on the way back, it's kind of the same thing happens in reverse with responses. So now to the green box. So the green box is all of the stuff that we generate, and based on a schema. And it consists of two main parts. So there's the message part, and this is the vocabulary types that we generate based on your schema. So if you've got like a top-level request, which is kind of request type, which one of the options is request type A, and maybe that has like a employee property, that's a kind of structured C++ type that you can instantiate and set the correct properties for the request you want to make. And then the application code will pass that to our send request client API. And then the second part is the schema util component. Now, the schema util component is like technically unnecessary. But what we do is we provide an API that is specific to the particular top-level request and response types in the schema, and our functions that will encode the request and decode the response from the different codecs as a separate function call. So why do we need that when we've got the templated version that is provided by the codec API team? Well, the reason to do it is to make sure that template instantiation of all of that codec code only happens in a single translation unit. And that single translation unit we can then optimize and remove debug information. And that essentially was part one of a previous initiative to reduce the code size used. Because if you don't do that, and you link together many parts of application code that call the same service, all of those different libraries will instantiate the same template code, and with luck, the linker throws away duplicate copies, but depending on how things are optimized, some stuff may be inlined and doesn't get thrown away. And it was discovered that when we created the schema util component, we had a kind of considerable win in reducing code size. So anyway, I did it the wrong way. First time, I went the wrong way. I knew I was going to, so I'm going to keep my thumb over the button. So this is like a simplification of a synchronous send request method that we provide, that we used to provide in our client API. And it's kind of a simplification. It's also got quite an old school interface that follows our conventions of the 1980s, I guess. So we've got a client class, and we've got a send request method. It takes an output parameter as the first parameter, which is like the response type. It takes a request by const ref, and then the third parameter is an encoding type, and that is an enumeration. So the important thing to note here is that the encoding type is a runtime parameter, and therefore there's no kind of like way you can tell from looking at the code which codecs are going to be used at runtime. It depends on the context in which this function is used. But this is templated, so this API works with any kind of request and response type because that's the template parameter. I moved my thumb, didn't I? I let my thumb wander.
Oh, you did.
Okay. So what we wanted to do is so in order that we could, so what Sherry was doing was with new libraries is making sure that they explicitly only supported one codec. What I wanted to do was to see if I could move to a way of doing things where the linker could discard the code for codecs that weren't actually used. Because while you can kind of like do some instrumentation to determine if this function ever called with anything other than the BER codec, if it's a runtime choice, you kind of rely on when you're kind of doing that measurement of seeing all of the scenarios during the time in which you do the environment, and maybe there's you miss some stuff because stuff happens in production in a different way somehow. Whereas if you've got like a compile time choice, if it's not used, the linker can throw stuff away. So what I did was, wasn't just me, it was my whole team, but we had a discussion and we kind of reckoned, well, if we can make the codec a compile time choice, then the linker can discard those codecs that aren't actually used. So we came up with a kind of parallel API, more modern send request, and instead of passing in an encoding type and enumeration, you pass in what we call a codec class. So what does a codec class look like? Well, it's kind of just like a really simple basic class that's got an encode and a decode function. The encode and decode are still templated on a message type, but there's no runtime encoding type parameter anymore because the encoding is in the class name here. So if I'm just going to quickly hop back. So you can just pass in a default constructed BER codec as the last parameter. You don't need to explicitly specify the template parameter. So it's actually kind of pretty easy and succinct. It's just as succinct. It's actually slightly more succinct than providing the enumeration, just because our enumerations tend to have longer names due to namespace qualification. Cool. So what did the schema util used to look like? It used to look very much like this. So what are the key points about this schema util? No templates at all. There are concrete functions, but the encoding type is a runtime parameter. So if you look at this interface and think, I wonder if this is implemented in terms of a switch on encoding type. If you thought that, you'd be exactly correct. And what that switch statement means is like whatever type of encoding, even if only one encoding always get passed in, those theoretical code paths to the other codecs still exist. So even if we move those, that codec code into a separate translation unit, it's still, the linker is going to need to link those into your executable. So what do we change this to? This is where I got kind of quite excited because I was actually doing some C++ that involved templates again and some funky stuff. So what I didn't change the schema util, I just added an extra interface alongside it. And I added member class templates to the schema util, encoder and decoder. And you can see that these derive from stood false type. And what they are is they're essentially their own is this codec supported trait. So essentially by deriving from false, this is saying this encoding is not supported. So the standard default classes don't support any codec. So if this is all that the schema util look like, then essentially encoding and decoding never work. In order to support a particular codec type, we add a full specialization of the member template for the codec you want to support. So this is a full specialization. So it's effectively not templated anymore. It's not a template anymore. It is a concrete class. This one is for supporting BER. It derives from true type, so I can do some trait evaluation. Being explicit about the traits, so it was just chose for simplicity, cleanliness of code. You could probably do some Sphinia or something, but it seemed like an unnecessary complication. And then if you support a particular encoding type, the specialization of the class has to provide an encode function. And the neat thing about this encode function is not only is it concrete, it's completely it's specific to a request type, but also there's no runtime codec parameter.
It is instead compile time.
Yeah. So the cool thing about that is, so what Sherry was doing was getting library owners to explicitly only support a single codec in both the old and the new interface. And what I was doing was saying, even if library authors don't make that change, if we change the way they're generated to use a new interface, they can still get that space advantage if nobody actually uses that, because with the modern interface, it's a compile time choice and the linker can discard the unused codec code.
What if the code you didn't need magically went away? And that's what CB called up, and it was a pure infrastructure win. There was just no risk to it. And we felt pretty good about that. So then we went on to figure out what else did we need to attack. And we thought we were going to tell people what should be in their libraries. And I'm sure you would all love me to come and tell you what should be in your library tomorrow. We took a lot of outreach and we took a lot of argument, but we wanted to first change the way the libraries were named. And the reason we wanted to do that was because it would be so much easier to validate. If we could just say, every library that ends in this suffix is going to have these rules. And we also wanted to mandate that if a library had any generated code at all, it would only have generated code. We'll get into that a little bit more later. But here's the weird one. The first thing we did is we made up two suffixes, service message and types. And every library that had a codec choice that could do request response would end in service message. And every library that only had value semantic types would end in types. And people were just fine with that. And the reason they were is because when services first started coming in, when I first came to Bloomberg ages ago and the dinosaurs walked the earth, we had actually done that for a very non-technical reason. A woman named Jackie Race and I were part of the architecture office. We were working for John Lakos, who you might recognize. Get his book. When I stand on it, I'm actually tall. Well, we were hand maintaining all of the link lines that built these executables. And in the beginning of the whole move to services, there was always one service, one client library. We, instead of having to negotiate what was calling what, and just 10 things need to move up and 15 things need to move down, we were able to say, this is a library we're declaring to be the floor. Our floor service message. And every new service message library would go on top of that. And it was no negotiation. It was always in the right place. It always had the right dependencies. And then people started realizing that these types were a great shared language, that they could use them across services or even use them without services. And they started asking us to have one library depend on the other. Now, there were already hundreds of these things. And the idea of every time these ads, and they were coming pretty quickly, were made, I was going to have to try to run dependency analyses on things. And, oh my God, if I move that up, these 12 things needed to move up too, and that needed to move down. It was just terrifying. So we went to CB's team, I think prior to CB, and we said, we want you to say that anybody with shared code, shared types, put them in a separate library. This way, hundreds of service message libraries would still be peers, and the few here and there that were like, it's just the beginning of the thing we didn't even know was going to start happening, those were the ones we would place carefully. And they pretty much went it above John's team's code because that was like sort of core BD, core Bloomberg, basically. And so when we said we would like to do that now, and we had other reasons for it, people were like, okay, what else is new? The funny thing is, it actually had a reason that we didn't even understand. First, now that people were making more and more of these shareable types libraries, they had to be just aware of their design. We are doing this to be sure. This is what's going in it. And also, when service message libraries, when things with schema utils depend on each other, any one task could only use one. So what would end up happening is if you have one dependency on another, you end up with code that is orphaned, bloated, and sometimes calling the wrong one. I think that's enough about that. So the other thing that happened when we had these two kinds of libraries is CB was able to take that original client API from CMake and make it even more specialized.
Yeah, so we had specific functions for generating types libraries and specific functions for generating service message libraries, and that made, it forced people to be explicit about their intent rather than just relying on properties of the schemas, which were a little bit kind of obscure to make that distinction.
There was one other thing. Now that you have these specialized APIs, they are basically not making any room at all to add anything but generated code to the library. Remember what CB said about stripping debug information at the very beginning? Well, the way that worked, it was not file by file. It was library by library. So if you had people mixing their generated code and their non-generated code, well, the generated code is like, we know it so well, there's nothing left to debug. But the danger of stripping out bespoke code was the debug information was a little bit harder.
Yeah, so I mean, for even predating the original CMake interface, during the kind of previous iterations of how we use the code generator, we were always trying to kind of like optimize and well, actually, at the time, it wasn't strip debug information as much as not generate debug information for the schema util components. And I mean, to be honest, I've disassembled some of these generated schema util, and it's obscure because it's just instantiations of kind of these very clever but a little bit obscure templates in the codec API. It's probably more difficult to kind of comprehend from a debugger than it is to look at the source code and to infer what's happening. So actually, I mean, and when we moved to CMake, the way that the CMake instructions work, we would strip debug information from the entire CMake target, which is essentially a library. So actually, this is actually a true example of the principle of least astonishment that was kind of really important. What we found is that with the older, more flexible CMake API, people were kind of like adding some generated code into a library with some stuff they'd hand authored, and the side effect was because they were using the CMake interface to invoke the code generator, we for free we're stripping the debug information from the entire library, including the hand-authored stuff. And more than once, application developers were surprised when they pulled a core file for a crash that had happened on production and basically found it impossible to debug the code that they had authored. So by using the modern APIs, which are basically kind of the interfaces around building a complete library, we made it hard for that problem to come. And that problem, it's almost totally invisible during normal development. It only becomes apparent, A, in production, B, when you have a production problem, and C, when the production problem is so intricate and gnarly that you actually have to be looking at a core file, which is kind of like not an ideal situation to find that you've built your library in a suboptimal way for debugging.
But there were lots and lots of conversations about this. Now I need 2 libraries. Now I need 3 libraries. People would complain. But when it was explained to them what was going on, if they left it all together, mostly they were okay with it. Except there were a couple of folks out there, a couple of teams, that had actually taken what the generator was doing and added an enhancement that was really good for the client library to have. And we were now making that impossible. And when they called up and they began to asking for exceptions, but I brought the problem to CB because they had a point. Why were we making this so tough? And CB made some tweaks.
Yeah, so we had a team that had some kind of interesting and reasonably sophisticated kind of wrappers around some of the APIs we provided, but they wanted like this extra component that was kind of give you like a compile time service version information, and it seemed a reasonable thing to want. So we added that as an option to the code generator to generate the file that they wanted to manually add. We can say, well, let's just generate it ourselves, and then you don't need an exception, and also you know makes your code simpler.
So we start getting a little more credibility here. And developers start coming to us and saying, we have some really good hacks that we hid really well. Or maybe the people we inherited the code did. We didn't know we were allowed to depend on other client libraries. So we've been like developing the same code under 7 different namespaces. Or, please help us fix this. A couple calls we got actually really shocked me. We had co-opted the suffix types. We really should have done message types or something like that, because types is a pretty generic word. And there were people using protobuf or avro, and we thought that they were going to ask for some way to be accepted from all these rules because we were validating against our generator rules. But what happened was they wanted to know why we left them out. All generated code or non-generated code in a library is a good idea. Can we work with them to learn enough about their code generator so we can help them have a set of standards too? And then we started attacking code generator options that people had gotten very fond of. There was one that was like bidirectional. It was great for a corner case, but it was in almost every cookie cutter. Teams had been adding this flag forever. It almost doubled the size of a client library. And it was a codec library. So it was like you'd encode and decode in one direction, and this let you encode and decode in the other. And we'd say, why do you need it? Well, of course we need it. It's always been there. But as it turned out, nobody did. And that was hard because we really had to make sure.
Nobody.
Yeah, and we really need to make sure.
Nobody.
Well, when you gave them an alternative, you built an entire alternative for a new kind of library. What, 2 were made?
Yeah, so I mean, there were a couple of use cases where people needed this flag. One was when a service was a client of itself, either directly or because somebody had implemented a proxy.
But in client libraries?
But another, because if a service is a client of itself, it kind of needs its own client library. But another big one was testing. We actually kind of like relatively recently, released a whole lot of helpers for the Google mock environment, which mean that it's not needed in that case either. So yeah.
So the code is better, the flag is gone, everything is smaller. And so CB and I, to end this chapter of our friendship and our working relationship, not this talk, God help you, it's not going on forever. We published the RFC. Except for that complaint, we basically get to turn these recommendations into policy. They're now being written into the validators. I don't know, people just accepted the changes. Very little argument. We learned a lot more about outreach. We learned to never just say no. People have good ideas, and you really need to consider every single one of them. That if somebody comes to us with a reasonable use case, we have to acknowledge we will either have a solution for them or they get an exception. That we are not going to stop them cold just because it's against our rules. If we did have a better idea, CB would take the time to explain it or teach me enough if they came up often enough so that I could credibly do that too. And finally, people will do the right thing if you ask them and you tell them why.
I did. I kind of mentioned it before. Actually, I've just thought of this, so I'm kind of surprised at this. But this is the stripping debug information is a classic example of this, because this was one of the rules that people kind of got really kind of irritated by. It's kind of, I just want to add these few files into this thing. And they didn't realize that there was a reason behind this rule. It's not just arbitrary that you shouldn't put the generated code in with the non-generated code. We had some practical reasons. And as soon as you explain that to people, generally, they're happy with it.
And the impact on the code base has been huge. Without an assignment, a team lead or manager telling us to do anything, we have impacted thousands of libraries. We have saved about how much headspace would you guess? It's hard because some of it was accidents that never
so
happened.
when we started to cooperate, and some of these tasks, these executable files were getting to like a really critical size, and it was kind of like a weekly exercise of which code changes, and not making code changes is not an option because you've got to support even your old functionality that you're not adding new stuff to. Sometimes has to support changes, time zone changes, regulatory changes that need little fixes here and there. And these just tend to increase the size of things. Sorry, what was the question again? It was
So
like how much
basically,
time?
can we tell?
So we had
we know what the space you got rid of, but we don't know the space we prevented, right?
Yeah. So I mean, there was a kind of high-profile tickets and meetings where we're kind of like examining individual changes for their size impact all the time. When I flipped the switch on not only the codec util compile time choice, but there was one other choice which we didn't have time to detail. We put these two switches in, completely transparent and safe change, flicked a switch, watched our headroom increase massively, and basically these painful exercises in working out what changes are allowed to in, that could stop. We had like 9 months of headroom during which other teams could pursue more medium and long-term efforts to make sure that we kind of like never hit the bad situation again. It was really rewarding.
And together we accomplished all this with overwhelming community consensus. People got used to talking to us. The negotiations were stopping, why should we do it? They were like, when, and can you help us? And well, that's our story. And we're gonna keep working together because we like it.
And we got faster, look.
That's true. You have time for questions if anybody's interested. We have 14 minutes. Does anybody have a question? Come to the mic, please.
What's the landscape of the C++ standard at Bloomberg? Are different teams, is it one standard mandated? Is it like, or different teams on different standards? Did that come into play at all?
You know at Bloomberg that we really support standards. So generally 2 at any one time. I can't remember when the split happened, but we still support C++03 for one of our architectures. And the other one is 17 going on 20, I think. 20. It is 20. 20, cool. And that's kind of, I find that quite interesting.
You could tell your friends in the room.
Because not all teams have to support all architectures. So, even our team as a core low-level library team, for our APIs and our code generator, we support both standards. But we have some services. So, our team is focused around schemas, so we actually have a schema repository. We've got a service which where you can register your schema, and it's a schema caching service. Those services we only provide on a more modern Linux architecture, so we're using C++. Well, I doubt we haven't had to put any new features in, so we probably haven't put any C++20 in there, but we could if we wanted to.
Okay. You look like you're online?
Yep.
Hi.
Hi. So as a result of all of this, did you guys see any culture shift in the developer community, or amongst, I guess,
I'd like to
how the different development groups work together?
I got put on an outreach team, we've always been doing outreach. I would end up on a Best of Bloomberg volunteer bus, and there would be 15 people telling my kids how I'd saved their life the other day by helping them delete or remove or whatever code. But we became a formal outreach team a couple of years ago. And part of what was happening is the more people learned that we actually were going to say, wait a minute, tell us what's wrong. Tell us where we're screwing up. The more they wanted to come to us and trust us with showing problems that they thought we could help solve. We also, Bloomberg is very independent. We operate like hundreds of different startups. People are not told what to do because they all have our clients are the app teams, but the app teams have clients that are paying a lot of money for the Bloomberg on their desk and using it to make a lot of money and trade and do things that are very time sensitive. So they are fiercely independent. As these teams have evolved, though, they have started creating like community architecture offices where we used to move code for them and help refactor. They took it over. We actually had to find more things to do. So these are people who are already very much into the idea that they could volunteer within their own community. We even have like guilds for that, and the C++ guild is one of them.
I wanted to answer some of this question, but I've now forgotten what the question is again.
The question is, did we change the culture?
I think we've been part of a continuous improvement in culture. I think there have been over the years there have been a lot of initiatives inside Bloomberg to encourage sharing of community best practices, both in terms of kind of use of C++ and use of our framework. So I think we've done an important step in that, but certainly not the only part of the initiative. One thing that I find particularly gratifying is as an infrastructure team, we provide documentation, but that can be a bit dry and people don't often read and look at it. But we have we have internal Q&A sites and we've got internal kind of group chats. One of the things that I kind of particularly love is the fact that I can go into a group chat and answer a question about a particular topic and explain it reasonably why. And then I'm busy for weeks, and sometimes later I'll come back and see somebody post a similar question, and somebody else not from our team will answer that question using the information. So it's great to kind of organically kind of get the best practices out there.
Same is true of our outreach team. I swear, I will at the end of the day look and see what questions came in, and all of the people who have worked with us in the past have just hopped right in. I almost never have to ask a question. In fact, we had enough time that we created BB Talks. So for people who might want to present.
You have enough time? Wow.
Well, we wanted to make it so that people who know how to present were all sort of there. So anybody who had a quick question would ask a question basically in a chat room where there could be 100 people who could help answer it.
300.
300. Is it 300 of the BB Talks?
No, I was thinking about people who could help answer on our particular area of infrastructure is kind of more like.
But and the other thing that was important is watching us change direction, watching us not be insisting that we are right, that ability to tell people that we know when we screwed up, especially when we attack namespaces. In fact, CB and I worked on changes on this stuff to help the namespace changes. The more people understood that we were gonna really hear what they were facing, that we were going to recognize that there were some things we thought were a good idea that turned out not to be, the more they came to us. And when I went to visit CB in London, there were about 15 people who just made appointments with me because they wanted to tell me other things they'd like us to work on. So yeah, it's kind of, you think they're gonna say, get away, you bug me, but instead they wanna help. It's very cool.
Great, thank you.
Any other questions? Hey.
Hello, I was just wondering, it sounds like this was a pretty substantial project, right, with a lot of people who were really interested. And I guess I was wondering, given that you made pretty substantial changes, I was wondering, what was it like, maybe just to anchor whatever metrics you want to provide, how big of a project was this? For example, you mentioned 15 people wanted to come and talk to you, right? And if 15 people come and talk to you and each of them wants okay, how do I adapt your thing to my use case, right? That's implicitly a request for a lot of your time. And so how did you manage that? How many resources did you have available to manage that?
Well, here's the thing, and this is one of the things that works so brilliantly. That's how I'm supposed to spend my day. I could handle so much of that. And then when I hit a point where I had not yet learned enough, or it was going to take a much more complicated change. Remember, I'm the journalist in a software shop. I could bring it to CB, and CB could be as social or antisocial as you felt like, but no, you got more done, right? Mm-hmm. You were, in a weird way, I was doing the time-consuming, talking to people stuff, and CB was really not only pointed in directions that would make fast improvements, but it happened where the only time sink was me.
Or I guess it sounds like you're saying on the technical side, there were not substantial technical complications to meeting these requests, or? Well,
there were, but at a certain point they start to repeat. So in the beginning, I bring a lot of stuff to CB, but at a certain point, okay, we've seen this before and I know how to help you. And it gives us a little confidence when we're dealing with people also, because we can tell them, okay, I know this seems scary, but guess what? I know all the steps you need to take next, and I could walk you through them, and we're not going to send you away and say, go learn them.
Yeah. So I think at the start of our collaboration, so just for a bit of perspective, our libraries and code generators tool, I had a quick check this morning. There are 6,000 libraries that are directly code generated. We have 17,000 different packages that depend indirectly or directly on me. So I there's no way I can inspect every use of them. So I think at the beginning of our collaboration, I very much had the attitude of I will look at something. If it's not actively terrible, leave them be. Let them do whatever. And you were much more insistent on well, why are they doing this? Is it beneficial? Is it, or should it follow a pattern? And I've been kind of won over a bit more into, yes, it should follow a pattern. And removing the exceptions, it was one of the key things is with the CMake tool, and especially the high level interfaces we put in, which is kind of create a library from this XSD and just do it the standard way. Having that standardize is what made it possible to do some of that codec util work, which was, so on the one hand, we changed our internal APIs to take advantage of this schema util member template and do all that trait thing. And on the other hand, we were changing the way the libraries were generated, so long as that stuck to a standard pattern. So with the standard pattern means that we can, that thing could actually work. We could make the change, flick the switch, and get the changes immediately. Didn't have to bug anybody to go, hey, you're doing something non-standard. If you could make the change to go standard again, it would really help us. Does that answer the question? I feel like.
And just one thought I just had, we had a lot of other examples of small things that we attacked. When I was teaching the presentation class with Andre, I realized we had way too many of them. We have shorthanded a lot of this. There was just a lot of small issues that on CB's team would have been untenable if there weren't somebody out there having the conversations, offering the assistance. And that relationship came back. And people showing us things that had been better hidden, that they had done in such a way that were taking up a lot of headspace, but at the same time would have been harder for me to find or for CB to find. Yeah, come. Shivam helps me run something called Show and Tell, where people in our team get to present once a month, and we coach them.
The really cool thing about Bloomberg is you get to go to conferences and get to speak to other people from Bloomberg.
So you mentioned that people were using code generators before they adopted into CMake.
Yes.
How did you deal with the people who were not moving to CMake, or how did you make sure that people moved towards CMake?
Oh, that's a really big one.
Yeah, that's probably a question for. So I talked about kind of initiatives through collaboration. So essentially, as you know, but for the benefit of everybody else, we have C++ Guild, which is all about the best use of C++ in, and their recommendation of you should move to CMake for XYZ reasons is kind of one of the big things. It's definitely not something that people would listen to my team directly just say you should use CMake, but it's got to be kind of a mutual benefit thing.
But you were telling me just before, it really massively helped the effort where we did not want people checking in pre-generated code. If the code was generated a while ago, God knows how it was generated and on what standard. And the move to CMake made it much, much easier to make sure everything was fresh every time.
This sounds like something you mentioned earlier, where if it's good for people, people will adopt it and they know about it.
So the other really cool thing is if you want to publish a service message library for your service, and all you have to do is have a CMake lists, which is a single CMake function call, and your schema. It's really simple and really easy, and it kind of looks neat, and nobody has to kind of go, oh, please regenerate or whatever. It automatically correct all of the time. So making it as simple as possible is good.
Yep. Brett, I can't hear you. Can you come to?
Brett is saying that the multi-project workflows were important for this, but you've got to reach the mic. You're going to have to.
Yeah, no, this is important. Yeah.
Okay. Sorry. All right. If you're careful about the way you write your CMake, and Bloomberg is, and you have nice helpers like these, you can take multiple CMake projects and configure them with one build directory. And this is very important to the users of these generators, because it's very common you're doing a full stack task. You're saying, I'm changing these types, I'm changing these the way the service implements certain calls, I'm changing the things that are calling that service, I'm running it all together with some sort of service level integration test, but I don't want to have 5 different work areas I'm building and somehow pointing them at each other with environment variables or sockets or something. That's not great.
Overwritten paths even.
Right. So what we can do instead is just say, okay, well, I have this full stack task. I have my Jira story. It says, as a user, I want to blah, 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 right? So you just take all the code that you might be touching and maybe stuff you might even just want to debug or look at. You throw it all in one work area, and then you just hit the build button. And then, so if you didn't use CMake, to answer the question we just had, you had to do it the horrible way. And if you converted to
CMake was more than one horrible way to do it.
If you converted to CMake by just clicking a new project button, copying your schema file into that directory, you could do it the nice way. And so that the return on investment for doing that Jira story was positive in converting just that one schema to the new CMake style. Like even just completing one normal,
this is great.
Sprint task was faster.
The person who overrun is going to be Brett, not
and
us.
I'm done. So.
Thank you. Okay, you've got 2 seconds, I'm afraid. So,
Well, I think we're the last talk today, so I think we could handle a couple
Yeah,
of
just in
questions.
the last maybe negative time that we have left, I
it's
wanted to
164
know,
minutes now.
yeah, I wanted to know if there's any lessons that we can draw for like smaller teams, right? So this is like huge Bloomberg project, but we have issues that are like cross-cutting issues, right? Even inside of a domain, right?
My
And so
team
can
has
we
5
scale this to those?
My team has 5 people. I just got curious and I found somebody receptive in another team. That's the thing. Nobody assigned this. Nobody said, hey, everybody, all those other people who are helping us, they are saying, we think there's some value in what you're doing. We're going to give you a little bit of time too. Sometimes they were saying, please leave us alone for a month or 2 or 3, and then we'll give you some time. And I had this habit of saying, make an appointment so we don't forget about it. But really, this is the weird thing. We didn't realize how big this had gotten until we were putting this together. I'm going to go back and tell my TL, do you realize what we accomplished here? It really was teeny tiny manpower, a lot of my time, but that's what I'm supposed to be there for. And it was everybody else just carving out a little bit of time from their day. It was a small team effort. That was the thing. And the fact that your team, if they wanted to update their generator styles and design, could come to me and say, can you help us out here? And I've been kind of doing nothing but for 2 years, or a lot of that for 2 years. That takes even less of your time. That was the magic of this. It was not an initiative anybody budgeted for. It just happened.
Cool.
Let me help.
Yeah.
Thanks.
Should we wrap up now, I think?
Okay.
Thank you very much.
I think we're supposed to stop, but if anybody wants to talk to us later, we were so excited that you came. Thank you so much. And, oh my God.
Thank you.